You know what keeps me up at night? This number, 55 billion. That's how many connected devices we'll have by 2025, pumping out 80 zettabytes of data. And if you're wondering, like I was, what a zettabyte is, well, if you started downloading a single zettabyte on your home internet today, especially if you're on Curt, you'll see in a minute, you'd still be downloading 300 years from now. We're talking about 80 of those. But now here's the thing. All that data needs to be processed somewhere. And not just processed, but processed instantly. I mean, think about it. A self-driving car can't wait for some distant data center to decide if it should apply the brakes. And a security system can't pause to ask the cloud if that's really a threat that it's seeing. When milliseconds matter, the old way of sending everything to massive cloud data centers, well, it's just not cutting it anymore. That's where edge computing comes in. Instead of sending data across the country, we're bringing that computing power right to where the data is created. Smart? Absolutely. Simple? Not so much. Because now we're talking new questions around infrastructure, around security, how to make it all sustainable, and so much more. Well, today on WWT Research, we are diving into our latest report, IT Infrastructure and Operations Landscape in the AI era. This comprehensive study reveals how organizations are actually making edge computing work in the real world. We'll explore real use cases that deliver business value and build strategies that scale. And to help us break this down, I brought in two experts. Jennifer Adefala is a strategy consultant with WWT. She's the person organizations turn to when they need to navigate the complex journey from cloud to edge to AI. This is who they call. This is why we call them. But she also works closely with Curt Stalhood, distinguished solutions architect. He's the one who takes these edge computing concepts and turns them into actual solutions that will work in the real world. My name is Robb Boyd. I talk a lot and host people that are smarter than myself so that we can all learn together. Welcome to WWT Presents Research.
WWT Presents Research.
Well, guys, it's really good to have you with us. And gosh, we've done this before. It's almost been 2 years. And obviously the technology keeps changing, but there are some specific things I think to really understand why this is so important right now, specifically edge computing and then this push from AI. But let's start on the edge side. Jenny, I'm curious, could you tell us why edge computing is important today? Why is it so essential for really real-time data, and why that distinction is important?
Yeah. So edge computing initially emerged to meet those low latency, high bandwidth needs like you think of real-time gaming, which requires 20 milliseconds for smoothness, and autonomous vehicles aiming at that 5 to 10 milliseconds. So essentially as fast or faster than the human eye. So by processing the data closer to where it's generated, whether on a device like a cell phone or a car, or maybe a nearby server, or it could be even in a data center that's miles away, edge computing delivers these rapid response times. But it isn't just about latency and removing those buffering windows that you might see from time to time. Another key point is that edge computing can reduce bandwidth and storage costs. So something that's important today. So imagine a congested road and it's filled with cars. Well, that's what happens when huge amounts of data constantly travel back and forth from a central data center over time. And by processing that data locally, edge computing eases that congestion. It lowers those storage needs and improves efficiency, especially in areas like rural areas with limited or costly connectivity. And it also enhances security by keeping that sensitive information local, supporting the privacy or maybe compliance needs. And so essentially, edge computing can enable faster, but also more cost-effective and secure data processing.
That's interesting, because what I hear you saying, correct me if I'm wrong, but it's really, when I always think about, especially at the top of a show, I always think about the distinctions on definitions and really saying, well, what is edge computing? So you could say what it is and what it isn't to make sure that we're all on the same page. And it feels like one of the big things you're saying here is that processing, where the data is processed, begins to define, okay, that's edge. And I guess we're saying it's edge of a cloud. Is it an extension of the cloud, and it's by necessity because the type of thing we need to do just can't be done effectively, potentially? And so edge is really maybe that link that could be holding back an application from being able to do what needs to be done safely, correctly, legally, whatever it may be.
Correct. It's just anywhere where the processing is closer to that end user, so wherever that device is. So a cloud is a data center, it's just further away, and then you
Yeah.
continue to get closer and closer to that end user.
Well, Curt, I feel like AI must be driving a lot of this. And I've learned how to overwhelm my paid subscription to Anthropic because when I start loading in, I notice how quickly I reach data limits because of the fact that it has to send the same stuff all over again. It's like a fresh question just with everything you've been doing added into it. I don't know if that has anything to do with why AI might be pushing this, but I can see where, wow, there's probably some different models with AI that are going to have an effect on whether Edge is appropriate or able to deliver it on it in a more efficient manner.
Yeah, I mean, absolutely. When we think about bringing AI to the edge, it really is, as Jenny mentioned, about the real-time processing of that data, right? I mean, we've seen a lot of changes in the edge industry and what we're seeing for workloads that are being stored out there, and AI is certainly, a top of mind right now. If we take a look at specifically like Vision AI, for example, one thing that's important about it with real-time processing is having the ability to make immediate decisions based on what that particular AI solution is looking at. So if we take, for example, a manufacturing line at a plant, right? We can actually use AI technology to reduce the amount of faulty products that are being spit out of a factory line floor by looking at that actual gear and using specific sensors to be able to detect that ahead of time before it gets boxed up and sent on its way, right? So thus we're taking, a reduction in faulty products, a reduction in warranty issues, returns, those sorts of things as part of that, right? And if we also take a look at like the retail space, AI can really enhance a customer experience. I mean, if you are looking at like personal interactions in that regards, right? If I walk into a grocery store and it happens to see me and it recognizes, what I've purchased in the past based on seeing myself in an image, it could say, hey, by the way, I know you buy this particular product, but this is actually on sale today, and it's down this aisle, and then I can actually help direct you in that pathway in order to get to it in that store, right? So it's really a great experience as we look at, how AI is driving a lot of those changes, but really it's about trying to get that data for that real-time processing is critical to be right there, specifically at that edge location closest to the IoT devices as possible.
Yeah, it sounds like you're really shortening that loop on how far something has to go, because if it comes back late with the answer, well, the defective product in your manufacturing example has already been boxed and out, probably when things are happening at speed.
Same thing if we think about like an end cap, somebody walking by, and inside of a retail store, they happen to walk by an end cap. And if it's already sending data off to the cloud or back to a main data center, that impact of that end cap sale could be gone for that particular experience.
Well, I like that part of your example where there's location services provided to route me, because I get frustrated like, okay, great. Yeah, I want that. And then I'm like, what types of technology are we seeing at the edge?
Beyond traditional AI, edge technologies leverage AI, right? But it's in specialized ways to solve those specific challenges. So in other words, it's all about the use case. I think how to answer this would be good to hear some stories of what we're doing with our customers today. It's using technologies like computer vision. So I'll expand upon that a little bit. Digital twins, digital humans, etc. So with computer vision, which interprets visual data from smart cameras, we've implemented solutions all the way from improving mine crusher efficiency by detecting rock jams in real time to restaurant industries where we've deployed or developed a food monitoring system to reduce waste, as well as ensure that the popular favorite dishes are out on the buffet line at all times. At events and sports venues, Vision AI minimizes those wait times by providing real-time updates of crowds at the concessions and the restrooms. With digital twins, so replicas of physical objects, so exact duplicates of a physical object and a digital object. We've modeled entire university campuses with the ability to replicate even underground, such as plumbing or cables. We've also created digital twins of our global headquarters, racetracks, pit stop areas, and we've added in with augmented reality. So augmented reality would be combining a real world view with a digital world to create those immersive experiences. And with digital humans, we've developed AI-powered virtual assistants that go beyond those traditional chatbots that can be used for customer service or maybe training. So lots of examples there, but hopefully this highlights how edge computing and advanced AI are transforming efficiency and experiences across industries.
But where does connectivity make or break these type of solutions, and how important is it? Because you're dealing with offshore type stuff, which is really limited on what it can connect to. And when it does connect, I imagine it's a lot more expensive. So you need to be delicate about what you're sending back and forth. But what's important about the connectivity equation in making decisions here?
Yeah, I mean, it really ties into that whole, conversation about real-time processing, right? And getting those immediate responses. I mean, having that data available has to be in high-speed connectivity along low latency, as well too, right? I mean, as you mentioned with the Starlink thing, right? People are expecting that sub 30 milliseconds experience to be able to do things like video streaming and gaming and other types of activities, within inside of a typical internet surfing, right? Where if we go look at the edge side of the house and the AI applications that exist, things like private 5G and Wi-Fi networks are really critical to those IoT devices in order to give that real-time processing and to be able to support that inferencing locally there at the edge. And, that type of data exchange happens to go across all industry verticals, as we think about these type of issues that exist today. And it's also one of the things of why we've talked in the past about, some of our solutions that we've developed around the 5G edge in a box, which is supportability for actually running a private 5G system underneath a single node's server, and being able to host an application directly within it. And what Jenny was mentioning earlier about, like the race car events and stuff like that, that we've actually taken those single edge boxes out to those facilities to be able to showcase that technology.
Just to make sure I'm not overthinking this in the wrong direction, how do most people come into an understanding that they need edge? Do most people know that they need this, or are they feeling something now and they're like, wait a second, this might be what I'm looking for? How do you guys tend to find them?
I really think as long as they understand, the latency impact, right, of that particular workload that they're talking about is going to be, one of those conversation starters when they think about whether or not that's going to be sufficient to run at the edge. And we often throw terminologies out like near edge versus far edge versus regional data centers, national data centers. The list goes on, right?
That
and really
complexity
depends on
is important to our career. Yeah.
Yeah, and it depends. It's OEM dependent too, right?
Yeah.
Because what people call edge can sometimes be different, because there is the conversations of cloud edge as well, which is a little bit different than what we think about when we think about a private cloud edge type of solution, where we're getting it out there to a facility or a gas station, and being a single server sitting in a closet in the back of a room somewhere. And that type of technology is really going to determine that, right? And that type of responsiveness. And we've had cases where we've talked to customers, and if we go look at like VR as an example, right? And we think about mixed reality, and it's going to be very much comparable to like the Vision AI conversation. We think about the IoT devices in those cases, right? In order to give a proper VR experience, they had to have a certain millisecond latency that had to be met, and they could not accomplish that by using cloud technology or their own, national data center connectivity. And so it immediately became an edge conversation. They said, look, we got to get this box like right next to those VR headsets in order to take and to have that type of millisecond latency response. How do we make that happen? And how do we do it effectively while still having centralized data, and connectivity for, the broader system to work and function? So that's a big part of that realization and figuring out where that's going to be at. I mean, as a gamer, and my kids are gamers, they, as you can imagine, that millisecond is critical, right? I mean, one extra hop and additional milliseconds, and you've got, people taking in, going out there and playing these multimedia games and having a poor experience because of it. And you don't want to have that, right?
Or losing, right? you missed the kill shot or whatever it is, that you needed to do. Yeah. What's important about this interconnection between cloud and edge?
By 2025, Gartner estimates more than 50% of enterprise data will be processed outside of traditional data centers or the cloud. And that's a powerful statement overall. But this shift highlights the need for the more of a hybrid approach. So that's where cloud and edge computing are working together. Think of it like they start working as a team. So edge computing handles tasks that need quick local action, like maybe AI models analyzing data right on the spot, while the cloud starts to provide the heavy lifting for large scale tasks like training those AI models on massive data sets. With this hybrid and often multi-cloud setup, businesses get the best of both worlds. So they can quickly process the data at the edge for instant needs, while leaning on the cloud for deeper analysis, or maybe larger storage or things that aren't needed quite as quick from a response time. This combination not only reduces the delays, but also saves costs and keeps the data flowing smoothly, which is most important, right? Making operations more efficient and ready to tackle those complex needs as they arise.
Curt, what is the reality of deployment and kind of figuring out where to start and go from in terms of what's important to understand first?
Yeah, I mean, I think ideally, when you think about these different types of edge application workloads that are out there, right, there's a ton of them. We've worked with different customers in these type of engagements where out of the box, they immediately think, look, we have an edge case here that it has to be positioned out there. Yeah, an edge case, and it is one of those things where we evaluate that and we help them through proof of concepts and leveraging our advanced technology center, to be able to get that type of solution built for them. And then we can actually go through specific performance and bandwidth testing to determine whether or not that application really is geared for functioning at the edge versus something that could be supported more in a centralized fashion. I can tell you that, in some cases, we do have some customers that start at the edge and then move back into the data centers when they realize it doesn't work or it doesn't have to have that type of, proximity to those particular devices and that they can accomplish what they need to do within a more centralized fashion. But for the majority of our customers, I mean, they're very much driven around proximity to the IoT devices and being able to get, that data there quicker and usually have good cases for that. I give you another example is one customer that I worked in over in the Middle East, and specifically they were looking at autonomous vehicles in those cases and looking at cell phone towers and having an edge in a box type of solution built around that. So as that car moved throughout the country and everything, it's constantly looking for a closer cell tower and needing that proximity in order to read the information off of the roads, process that data back of the edge device, and be able to spit that back out to the car in order to give it proper directions through autonomy, right? And those type of technologies that exist out there couldn't have been happening without edge technology in place and having those servers. I mean, you imagine that we've got data centers all over the place, but still having to shoot something halfway across the country in order to get data back to a car in a relative fashion. I mean, here we're in deer season. So as you can imagine, if you go out in the evening time, you can't drive anywhere without having a deer in front of you on the road right now. So it is one of those things where autonomous vehicles is going to be critical to have that type of impact and that data being in front of you to have those real-time decisions on steering it. So,
Curt, are you seeing, or have you, either of you seen changes with regards to like VMware Broadcom? How are customers treating some of the changes there? How does that affect the edge game? Are there new opportunities? What kind of things should we be aware of?
Yep. So really good question, actually, because as we can imagine with Broadcom's acquisition of VMware, things have kind of changed a little bit, from a very direct path of looking at specific OEMs to now having a broadened look at whether they're running, a virtualized workload or a containerized workload, whether that's actually either in the data center or out at the edge. It's kind of a toss-up, right? And so we are actually spending a lot of time in our advanced technology center and helping customers to explore the different OEMs that exist out there, not only from specific retail products to looking at even open source solutions to figure out what's going to best fit their needs. And so we're actively going through these different types of proof of concepts and executing different types of test plans, everything from performance to high availability considerations to just initial things like stand up and how difficult it is to, migrate from one product to the other in order to really look at, what are my best options here? And should I look at things like a dual vendor strategy or a triple vendor strategy, or just staying with the Broadcom solution as part of that model, and it's exactly what we're helping them do, and that's why we spent a lot of time building edge solutions specific around a variety of these different OEMs, including Broadcom.
Well, and that's good to hear, actually, because so it's not as if anyone's saying, for whatever reason they want to cite, and there's many in different directions. It's not a matter of saying can't use virtual machines anymore. You're going to have to jumpstart your containerization journey, which can be very painful, if not even possible for many people, especially not quickly. That's a wholesale change. But you're saying there's a lot of different options, very application specific, and this is the type of thing you guys have been doing with customers.
Yep. Yeah. A lot of our OEMs specifically have actually been adopting, development changes in their own products in order to adopt more virtualization standards where they started with containerization and now they're including virtualization so they can actually host and be able to build out these different types of virtual machine workloads, to move them from VMware into a different product line. So it's interesting to see this drive
Yeah.
across all these different OEMs and including the open source, models that exist today. And to the point that, whether one customer chooses one product over the other, I mean, we're really here to help actually design, architect that solution across the board and help them with those migration strategies should they go down that path of migrating away from Broadcom as part of this mix. But to your point earlier, the applications, right? I mean, containerized workloads, not every application out there is ready for it. So there's a lot of VMs out there, that are built off of it. But there are some customers who take the point of saying, look, we're going to stick with our virtualized infrastructure underneath VMware. We're going to build our edge sites underneath, VMware for that particular need. But we're also going to take a container first strategy moving forward. And so they will either choose, VMware as part of that container strategy or an alternative. And for anything new coming on board, they'll make sure that that's actually going to be a containerized workload, right? So it's that dual vendor strategy type of look at, how we adopt and migrate workloads for the future.
That's an incremental change is not easy either, especially, running two dramatically different things. But what does the future hold for this?
I'd say picture the future of AI at the edge where companies mix and match multiple cloud providers. You're already seeing this today. Almost all major companies are with multiple cloud providers already, but mixing that with the on-premise or edge infrastructure. So getting these setups that are ideal for whatever problem they're trying to solve. If it is something that needs the edge, or maybe not, then they'll leverage the cloud more. But it's going to get more complex, which is sometimes not the best thing to hear because you're bringing a lot of things together. But it is a model that's going to add, I'd say, flexibility. It's going to lower costs. So you can imagine, just because of COVID, everything kind of rushing to the cloud or the bandwidth kind of concerns. So people are being more hypersensitive about the costs today and wanting to figure out, how to optimize costs overall. It's also going to, you hear companies like the NVIDIA GPUs and AMDs and Intel's, so accelerators, high performance architecture, you're going to start hearing more and more. And it's going to be, those accelerators could be happening at the edge, where that data is generated, making it the real time analytics being faster and smarter without always depending on kind of the cloud resources. So you also have to be mindful to keep these systems efficient by understanding power and cooling and storage and all those other things that go along with it. Kind of my analogy would be keeping a fine-tuned engine to run smoothly for the long haul. So whenever you're thinking of something new, that would be a great time to look into that. And really just think of it as cloud and edge computing becoming invisible enablers to solve whatever unique challenges you're trying to solve and really pave the way for innovation across multiple industries.
When it comes to differentiating from your competition, whether it's innovating faster or delivering something that someone else hasn't, it still feels like a lot of that maybe is a little bit more commoditized in the core, oversimplification, but the differentiation is happening at the edge. And this is where people really start to pull apart from others in terms of being able to do their job better, perhaps. Your thoughts on the future of edge and AI?
We're seeing a redesign of how those edge systems are being built, right? Where there's certain scenarios where a small footprint is the best optimized footprint, right? As we go back to the Vision AI conversation, and if I can get a tiny little desktop box, that I can mount on a wall somewhere and then hook in a few cameras to be able to do the Vision AI technology, and then hook into a public cloud in order to do my inferencing, I'm good to go, right? Yeah. But now that I'm changing, how I do things and having to get that data more real-time processing and having that availability there, I've got to have GPUs for inferencing. I've got to have, bigger boxes. Well, GPUs equals loud servers, right? That's the way to put it.
Heat.
It's because you have a lot of fans, heats, power, cooling, et cetera, are all part of that. So it changes how we're designing those edge solutions for the future. And I think we're going to continue to see that growth. I think we may actually see even in larger systems that are being built around those designs of those AI systems that exist today. And some of the stuff that we're testing or things like, single 2U boxes with 4 GPUs in it. And in order to provide all your local inferencing needs with inside of that system. And imagine having that inside of a retail storefront, or, just your regular restaurant chain, and being able to provide a different type of experience overall that would include not only AI, but can also loop in the private 5G and the Wi-Fi networks all in the one. So you have a real, personalized experience when you walk into that store, from, ordering food at a kiosk to sitting down and connecting into the network and, communicating with AI to, it's going to be a completely different design as we look into the future.
Yeah. Well, I like that, because you guys are working, it sounds like, on the modular kind of turnkey approach to make that more, because I would imagine what characterizes a lot of these deployments is the fact that they're not in places where a truck roll or its equivalent is going to be very feasible in a lot of situations. So you need stuff that's just at the most maybe a power cycle or something that you ask someone to do, assuming you can't do that remotely. You guys are very well prepared to take in customers, it sounds like, at all degrees of capability, whether they've experimented with something. And is it safe to say that we're beyond the days of, I remember quite a few customers, and this is years ago, but it was always fighting the notion of, well, we got this working really well in the lab, but they never actually, and then starts to go into deployment without testing, well, what are the latency issues that you might run into in a real deployment or in a very specific deployment? You guys provide that kind of guidance to keep people from those potholes and all the other ones that I don't even know to ask about, I'm sure.
Yep.
Yeah.
And I'm going to drop in a pun. We've been doing bleeding edge technology now for about 6.5, 7 years between Jenny and I working on this. And so we have seen that transition, right? Where it's what is edge? How do we make it work? And how do we make it function to, oh, that sounds great, and then they run a proof of concept or something. Okay, great. We're not ready for it. And then they sit for a few years on it. And then now we're at that stage where, because of AI and other solutions out there, that, we have that drive. And so they're now rolling that into production environments and getting caught up in that need for edge at this point in time. So it's definitely a transition, but ultimately, that's what we're here for, is to help guide people in that direction, leverage our ATC for those capabilities. And, whether it's building and testing inside the AI proving ground, or, building independent, proof of concepts to validate whether or not, latency is going to work for this, and whether you have the performance metrics to be able to meet this, and lining the right hardware with that particular edge solution as you move forward into a production.
Yeah, it's not a recipe that you can just simply roll out everywhere and everybody uses the same thing. And so I'm glad you guys have these capabilities and the ability to test them and showcase exactly why you're making the choices you are, or letting the customers make their choices. Well, Curt, thank you very much.
Yep. Thank you.
And Jenny, thank you very much.
Thank you.
Well, the future of computing isn't just about cloud or edge. It's about having the right compute in the right place at the right time. And for many organizations, that means bringing processing power closer to where the data is created and also where it's needed. Well, WWT's research shows that this isn't a future trend. It's not coming up soon. It's happening right now. From retail stores preventing theft in real time to factories making split-second quality decisions, edge computing is delivering real business value today. So I encourage you to get your own copy of the research report. I'll say it again, IT Infrastructure and Operations Landscape Report in the AI Era. And remember, WWT has a wealth of experts like Curt and Jenny ready to help you navigate these decisions and find the most efficient path forward for your organization. My name is Robb Boyd. Thank you so much for joining us.
Eaton is an intelligent power management company dedicated to improving the quality of life and protecting the environment for people everywhere. We are guided by our commitment to do business right, to operate sustainably, and to help our customers manage power today and well into the future.